My name's Kelly Grizzle. I live and work here in Austin, Texas for a company called SailPoint. And I was pretty pumped when I heard from Travis that they were coming here. I worked with him actually years ago, kind of in another life, in the early days of SCIM. And he was actually one of the early people that worked on that. So it's been a while since we've connected. It's good to see him again. So today we're going to be talking about SCIM, which I worked with Travis on. This isn't going to be a real technical talk. It's going to be sort of talking about the journey that we went through creating SCIM. And we're going to talk about what is SCIM, if you haven't used it before, haven't seen it before. Talk about why we created it, some guiding principles that we followed while designing it, challenges that we came across, and then talk about some experiences in the real world that we've seen. So what is SCIM? Other than being an acronym, it's a long set of words. It stands for the System for Cross-Domain Identity Management. And essentially what that means, all those words mean, is that it's just a REST API for identity management. So if you need to create users, read users, update group memberships, things like that, it's a way to do that. It's a standard for that. And the goal from the beginning has been to make it fast, cheap, and easy to move users into, out of, and around the cloud. And so that's kind of what we set off to do. But why did we create this? It all started like 8 years ago. In the summer of 2010, this was the very first Cloud Identity Summit, which is another cool conference. And it was a hot summer in Austin, so luckily this conference was actually up in the mountains in Colorado, which was a little bit cooler and nicer. And there was a bunch of identity geeks gathered together talking about kind of the state of affairs in the world. Things were actually looking pretty good in the identity landscape at that point, because standards were starting to pop up and they were awesome. So OAuth had come on the scene and was starting to get a pretty good market share. This was the OG OAuth, not OAuth 2, but it handled it standardized authorization. SAML also was out there doing a standardization for single sign-on or federated identity, and so it had gained a lot of popularity too. OpenID Connect was nowhere to be seen yet. It was sort of a twinkle in Nat Sakamura's eye at that point or something, but it wasn't around. But these two were kind of ruling the land, and some of us that are into thinking about identity a lot saw that there was a hole in this puzzle. What about identity management? We have ways to authorize, we have ways to authenticate, but how do you actually get those users up there that you're going to deal with? Because identity is really, the center of almost every service or product out there. They all have to have it. They all use it for security, you use it for preferences and all that sort of thing. So you've got to have it. The problem was that there was no standardized way to do this. And so every service out there was a lot of them, had these APIs to manage identity. The problem was that they all looked completely different. This was sort of in some of the earlier days of REST, and so you saw a lot of like SOAP and XML still. You saw a lot of different formats, a lot of different ways that people represented things. And so these identity APIs couldn't talk to each other, which was causing a lot of friction. And so the solution, of course, seeing the popularity of OAuth and SAML, we decided, hey, let's go and create a standard for this, and try to solve this problem. So we were kind of young and naive at that point, and we're like, okay, we've got this great idea. How do we take this great idea and get to world domination? And we didn't really know. So we just dove in head first. And we really wanted to move quickly when we started. There was a lot of interest in this. There were people that were kind of sold on the idea of needing an identity management API that was standardized, and we wanted to make some quick progress on it. And so to do that, instead of going and trying to create a standard from the get-go, we started with this group called the Open Web Foundation. And essentially what it is it's a way to have different people from different companies and different places come together, share ideas, and share intellectual property, and it takes care of all sort of the legal ramifications around that. But there's no process at all. It's kind of like if you can get in a room and say, yeah, we get along, we can come up with some ideas, then you can go and be happy. And so that's what we did. We started working on this. It took about 6 months to get SCIM 1.0 out the door from when we started, and another 6 months from that we had SCIM 1.1. And during this time we were really focused, and this is when I worked a lot with Travis. We were focused a lot on taking these specs that we were writing and actually implementing clients and servers, and we would sort of aim them at each other, and if they collided and exploded, then we'd obviously done something wrong in the spec. And so we found any spots that weren't well specified in there and kind of tried to tighten them up or clean them up, try to fix some of the ideas that we had. But at that point, we'd sort of gotten, by the time we hit 1.1, we'd gotten pretty much as far as we could go in our loose standards body, our loose OWF organization, because a lot of the companies that we were wanting to adopt this were large companies, and they sort of have policies in place that something has to sort of have some sort of seal of approval on it before they will adopt that technology. And so the OWF was not something that made those companies comfortable, you know, whether that was good or bad, I don't know, but we had to take it through a more formal and rigorous standardization process. So we took it to the IETF, chartered a working group, and spent some time working on SCIM 2.0, which is now out. We've got a few RFCs that are published about that. So during this process, you know, we had our brilliant idea. Let's create the standard API. We want to achieve world domination. How do we get there? We followed some guiding principles that we thought would get us there. And the first of which was simplicity, right? Keep it simple, fill in your S word on the end. And actually the original name of SCIM was the Simple Cloud Identity Management. And the idea here was that if we made an API that was awesome and, you know, could slice and dice and make potatoes if we wanted to, make French fries, that's great. But if it's too hard to implement, the people that we want to, you know, collect mindshare from to achieve our world domination weren't going to come to the table. And so we wanted to try to make it as easy as possible for people to implement either a client or a server. So that was sort of what we did. We had this sort of 80-20 type rule where if something was useful to like 80% of the people who are going to want to use this spec, then, you know, it went into the spec. If something just fell into that like 20% use case where not that many people would be interested in it, it had this high level of scrutiny that, you know, usually those are sort of the more complex use cases, and a lot of them we just said, you know what, we're not going to do that. We'll leave that if somebody wants to create an extension or something like that, but we just left it out of the core APIs. Another thing that we did was, you know, we kind of stood on the shoulders of giants while we were doing this. There was, like I said, there was a lot of APIs out there already that did identity management, and we didn't want to reinvent the wheel necessarily. We just wanted to take ideas from all those and find the best practices and pull those together. And so we surveyed a bunch of APIs and looked at what they did, and we found common themes, common patterns, ways that they represented accounts and users and groups and how they managed that. And so we use those as sort of a baseline. There's something called portable contacts, which we use as the basis of the schema, you know, to define what a user and a group look like. We also used something called OpenSearch as our query language for your query params. And a lot of our use cases were gathered just by looking at these APIs and seeing how users were using them. Another thing that we kept in mind was Pastel's law, And John Postel was this fuzzy-faced nerd back and worked for DARPA back in the 70s and 80s. And he worked actually on early versions of the TCP protocol. He wrote some of the first specs for TCP, and he created something, you can go read the TCP protocol and actually see this in there. He calls it the robustness principle, and says that TCP implementation should follow a general principle of robustness, be conservative in what you do, be liberal in what you accept from others. The idea here is that we want to ease integration, right? We want to get this world domination, so we want people to be able to, these APIs to be able to talk together well. So what this means is that if you're writing a server, if somebody sends you a response that may look a little bit off, try to just deal with that. Don't just break immediately. Try to deal with that. If you're a server, send everything you can as well formatted as you can so that you're not breaking clients, but be a little bit more robust on what you're allowing in the front door. And finally, I think one of the most important things that we built into the spec, and really I think this is where a lot of the longevity of this spec has come from, is extensibility. You know, we had a bunch of smart identity geeks together who had seen a lot of use cases, but we knew that we hadn't seen all the use cases out there. If anyone here is in the identity field, you know that every identity is kind of a unique snowflake. They all look a little bit different. They all have different attributes. You know, some people like to capture different information about their users. And so we built extensibility into the spec from day one. And so if you look at RFC 7643, that defines the SCIM core schema. And in there, we define what the user basically looks like, you know, which attributes, first name, last name, email addresses, things like that, and a group, and how users are members of groups. Along with that, we defined a language for defining schemas. And so you can use that to extend the base schemas. If you want to make a new type of user, you know, my API Summit user, you can extend the core user and add some new attributes that you want in there. You can also create your own object types. So if you care about more than just users and groups, you can create new object types, Internet of Things devices or whatever. And this has really helped a lot in people being able to use this in real world situations. If we didn't have this, people would take SCIM and throw it out the window immediately, because while it hits most of the common use cases, if it's not flexible enough, it's not going to meet any use case, right? Because everybody has a little bit different needs. And so in the server, there's kind of built-in introspection for this, so that you can ask the server, you know, what types of resources do you have? What are the endpoints that I hit? What schemas are associated with those objects? What are the capabilities of this server? You know, which type of authentication and authorization scheme should I use? So let's talk a little bit about challenges, because we did bump into a few along the way. You know, we didn't get everything right from the get-go, and there were some kind of things external to us that that made things difficult. So challenge number one was that when we took this to the IETF to get it standardized, progress, you know, they're good at kind of taking progress and slowing it down to a glacial pace. It actually, you know, like I said, it took 6 months to get from nothing to SCIM 1.0. It took 6 more months to get from SCIM 1.0 to SCIM 1.1. It took 2.5 years to get from SCIM 1.1 to 2.0. And, you know, there's kind of good and bad that comes from that. The good is that you have the seal of approval from the standards body. The other good is that you get a lot more eyes looking at what you're working on. And so people that may have a different lens on the world can find things that you're doing that may not quite be right. And so they're actually able to help in a lot of ways to make recommendations on things we should change. But it was slow and it was painful, but we made it. All right, so patch. You know, you've got your normal REST type verbs, post, put, delete, get, and then there's also patch. And everybody kind of understands what all those first four are supposed to mean. The last one can get a little difficult, especially when you're living in the world of 2010, 2011, and patches just barely making it onto the scene at that point. And so, you know, we were trying to figure out what patch meant and how to implement it. And the original use case that we had was, you know, it's nice to be able to patch and, you know, change little pieces of an object without doing a full put and replacing the whole thing. But the original use case that we had was for our group objects. And a group contains a list of members on it. That list of members in a large system can be, you know, on the orders of thousands or tens of thousands. And so to go and fetch a group and add one user to that group and then put that group is not very efficient. And not only that, if you're doing that and there's a high volume of change, you can real easily get into concurrency problems. And so we needed to implement patch. We couldn't use something that used a list index because list indexes might change, you know, with that high rate of change, list index might change. So we can't say, you know, remove item 4 from this list, because by the time that we go to remove it, item 4 might not be Bob anymore. It might be Joe, right? And we don't want to remove him from that. So we came up with patch. We actually implemented it twice, once in 1.0, 1.1, and another time in 2.0. And what we ended up with was something that is, frankly, kind of a pain in the butt. It works, but it's complicated, and you know it's not very easy to implement. And so I look at this and I kind of cringe and wish that we had kept that first principle in mind as we were working on this. Keep it simple, because the use case we were trying to solve was pretty simple. Add and remove members from groups. Maybe do a little bit more than that. We tried to boil the ocean and make it so you could patch, you know, you could patch everything in the world. You could patch your next door neighbor's dog if you wanted to, which made it hard to implement. So I wish that we'd taken our own advice and actually kept things more simple. It would have helped implementation in the long run. The other challenge that we saw was, you know, we had these giant plans. I don't know if anybody here used to watch Pinky and the Brain, you know. What are we going to do today, Brain? You know, we're going to take over the world. Yeah. And so, you know, we were kind of sitting there like the brain and, you know, we're going to take over the world. We're going to dominate with this thing that we're creating. And, you know, it took a while, actually, for adoption to pick up here. And that slide that I showed earlier, the world domination slide, you know, that's just a fraction of all the people that implement SCIM now. We've got all people from, you know, Facebook and Google and Microsoft to like these tiny companies and open source projects. So we're getting there, but the initial adoption was pretty slow. And so what we did to help that was, first of all, you know, if you're going to create something like this, you need some evangelists. You can't have just tech head nerds, or if you have tech head nerds, they need to be willing to get out from behind their computer screen and talk to people and let them know and sing the glory and the praises of what's going on with what they're creating. And so you need evangelists and kind of a lot of them to do this. Another thing that we knew that we needed from day one was to get some of the big players on board, right? We knew that if we could get Salesforce in the boat, if we could get Google in the boat, that a lot of people need to integrate with these platforms, right? A lot of people need to do identity management with these platforms. So if we could get them to adopt SCIM from the get-go, that would sort of have this gravity that would just sort of suck people into it. So we tried to do that, and I would recommend that if you're, you know, thinking about trying to dominate the world. It's good to have big friends out there. But even with all that, it took a while before we sort of hit critical mass and hit that hockey stick curve of adoption We had we had implementers trickling in, trickling in, trickling in. We've sort of hit that inflection point where we're seeing new implementations pop up all the time. I can't even we have on our simplecloud.info website, we have a list of all the implementations that we know of out there, but we can't even keep track of everything out there anymore. So that is missing a whole bunch. So it takes a while. It takes a while to get there. So let's talk just a little bit about what we bumped into as we saw this kind of getting played out in the real world. The first was quite a surprise. The initial name of SCIM was Simple Cloud Identity Management, and the mission statement was to move users into and out of and around the cloud. What we saw was actually the very first real-world, large-scale implementations of this were not in the cloud at all. We saw it. Folks like Intel, NBC Universal, they came to us and they said, "Hey, I'm using SCIM." I'm like, "Cool, what are you doing with it?" And they said, "Well, we have all these systems behind our firewall that need to be able to communicate identity information to each other, and we're having a really hard time with that. And so we chose to implement SCIM. So they would kind of create a SCIM server that's set in the middle of their infrastructure, and everything would go through that. And so it was just kind of interesting to see how sometimes you build something and you have these grand plans for world domination, and somebody takes it and runs with it in a direction that you totally did not expect. But it's cool to see what they're doing with it and how they've sort of made it their own. Another thing that we have seen is extensions on top of SCIM, taking it outside of the realm of core identity management. And there's been a number of these, but one that's near and dear to my heart because I've worked on it was for privileged access management. And privileged access management, if you're not familiar with it, is software that kind of helps you to lock down highly sensitive information in your organization. Usually it's used to store credentials for very privileged accounts. Things like, think of your DBA for your production system, or your website admin that can do a kill-9 on your production web server or something like that. These types of accounts, right? They're extremely powerful. If those credentials get leaked, it's no good. So people want to monitor these and really lock down access to them. And the way they do that is they take this credential and they put it in the PAM system in what's called like a vault or a safe or something. They all have different names for this. Some are trademarked, so I don't know even what I can say up here without getting sued. But they put these credentials in a vault, and if somebody wants to use them, if DBA wants to go and create a new index or drop a table or something, he actually has to go into the PAM system and say, "I want to check out this credential." And it will either give him that username password so that he can use it, or it will connect him automatically to the system he's trying to access. It does a lot of other cool stuff too, like rolling passwords, so that they don't, if they get leaked, then they're not exposed for long. It monitors who's using the password, which is really important for like a shared account, because if you have 10 people using this DBA account and somebody just accidentally dropped your customers table, you probably want a finger that you can point at somebody and say, who did this? And so it monitors who's using that account at any given time. But we saw a kind of a big, a big correlation between these two worlds of identity management, identity governance, and PAM. And they had a lot of similarities, they had a lot of synergy between the two of them, but there wasn't any way to communicate. And so we wanted to create another standard between identity management people and PAM people, so that we could communicate things like, what is a safe? What does a privileged account look like? How do people get access to these things? And so we created an extension on SCIM, a PAM extension, and it defines PAMI type concepts, things like safes and vaults and users accounts and things like that. And it's actually kind of taken off. We've seen a lot of the PAM vendors and a lot of the identity management vendors start to implement this, and it's really cool because I only had to write this once, write my PAM client once, and these vendors go out and do the hard work of creating these PAM servers, and a new one implements one, and my product can talk to them automatically. So it's pretty cool. We're starting in the early stages of trying to take that through the standardization process as well. And there's a link to that if it interests you. Okay, so this is kind of into the presentation. If you want more info on what SCIM is, I would say go to simplecloud.info. That's your starting point for everything SCIM related. It'll point you at the specs. It'll point you at mailing lists. It'll give you an overview and show you the implementations. These are the two key RFCs out there. 7643 defines the API, how you define the schema, what a user in a group is. 7644 defines the REST protocols that are involved. And at the bottom there is how you get a hold of me if you want to chat some more. So, or if you need recommendations on where to go see live music, I can help you out there too. And that's it. So.